Hi there guys, it's me, A148, or Ash148 ton. It's a couple minutes after the last video. I just wanted to get out this information as fast as possible, since it's fresh in my head and I'm thinking about it. So, here we go. So today we're going to be talking about SohCahToa, from the basic 30, 60, 90 triangle. Based off from that. I'm sorry if you hear the basketball, I'm kind of watching the Badgers kick some butt, so to say. And yeah, I'm just gonna rewrite my 3 there. I'm terrible at writing 3s, as many have told me. So we have our basic 30, 60, 90, and what we're gonna be talking about today is, we started off with our basic 30, 60, 90 in the last episode, so now we're gonna be talking about the next basic that you have to go into Trig knowing. The last episode was something that you learned in Trig, but this is something that you have to know before. So, I'm gonna just go off by saying that theta 1 and this is theta 2. Eventually, we're gonna be making this chart that has what this means, or sine, cosine, and tangent, and what each angle means based on the triangles. So, what we're gonna have to make here is what these mean. I'm gonna make that for you guys. So I'm just gonna use theta 1 for all purpose reasons, just because it's an unknown at this point, because we don't know if this is 30 or 45 or what the heck this is right now. I'm just going to call this an unknown triangle and say that theta 1 equals unknown. So we're going to use theta 1 as our main angle. So we're going to just call it theta. So sine of theta equals, no, the O means opposite. I'm just going to call it O, and that means this is the opposite of theta 1. That's the opposite of this exact angle. And then what this H means is the hypotenuse. That is what we are going to refer to that as. So, and then we are going to refer to this side as the adjacent, as we will find out. So we have the sine of theta equals the opposite over the hypotenuse. I'm going to define these a little bit later in this episode and say what the heck they are, based on basic stuff, on a XY coordinate plane. And then we have the cosine of theta, which is equal to the A adjacent, this side, over the hypotenuse, again the hypotenuse. And then we have the tangent. Now the tangent is typically referred to as later as the sine over the cosine. No, but meaning that we have that, we can say that the tangent is equal to O over H, and then A over H. Now, many people don't know how to do this. What I like to do, honestly, is we can just cancel out the H's, but that's not how we're taught in math. We can just cancel the H's since we know that they're going to cancel out eventually, but we're going to do O over H and A over H. And we're going to have that simplified to tangent is equal to the opposite over the hypotenuse, and we have to multiply that by the reciprocal of this, meaning that we're going to take the A over the H, and if it's, this is basic, we're going to be taking 1, which is equal to 1 times the hypotenuse over the adjacent. This is the reciprocal of this, and yeah, so then we have to multiply that by H over A, and then we cancel the H's, is equal to O over A, or the total. Yeah, I knew I wrote something wrong there. And yeah, so the tangent is then equal to the opposite over the adjacent. yeah, so that's basically SohCahToa right there. Now we're going to be defining this in x and y coordinate planes. So I'm just going to get rid of all this stuff on the bottom, and since we know the definition of this and we know all of this, we're going to go to the xy coordinate plane and call random angle theta. And since this is the x and then this is the y, I'm going to rewrite that. We can say that we have the x value right here and the y value. So we made a triangle because we have the 90-degree angle right there. We always need the 90-degree angle, right? Since this is our x value and this is our y value, and then we're always going to call the hypotenuse, even though it extends infinitely, r. Within this triangle, we're going to call it r. There's no reason why. I call it r, everybody else calls it r. So what we're going to do is we're going to make this into other terms of this. So we're going to do sine of theta. This is equal to y over r. Alright, because it's the opposite, y over r, the hypotenuse. And then we're going to do cosine of theta is equal to the adjacent x over the hypotenuse r. SohCahToa. We can consider several different things on this. And then tangent of theta. Now, 1 second. Yeah, don't know what the heck that was. We can either go by Toa, or we can go by what I said before, but we're just going to go by Toa, which is the opposite y over x. And we can reverse this and figure out what the heck I mean by the other stuff, and we don't really have time for that right now. So that is the basic of what we're going to be using throughout this whole entire math trilogy. And in order to find the angles, we actually have to use the other stuff. So now we're going to use SohCahToa to figure out something else, to fill in this chart partly. I haven't told you guys about 45-degree angles, so we're just going to do 30 and 60. That's the only ones that we need right now. And so we're going to do the sine and the cosine. That's all we basically need at this point. So what we need is that, so in a 30, 60, 90 triangle, we're going to be going back to the 30, 60, 90. So we have our basic right here, and I'm just going to redraw that. The redrawing part is always fun, right? I'm just going to extend that, and we have our 90, we have our 60, and we have our 30. Then we have our x, our 2x, and then our x squared root of 3. Alright, so now what we are going to do is we're going to use our basic 30-degree angle and figure out what each of these are. So now, I'm going to get rid of these. These you should have written down in some sort of note form eventually. That's all basic. So now we're going to be using SohCahToa, and we're going to be using our 30-degree angle over here to figure out what these each values equal. These are going to be our basics for later. When we get into more complicated things, you're going to be needing this chart for several different things. But yeah, so now we're going to be doing the sine, which is the opposite, sine of theta, meaning 30. I'm just going to put 30 into there. Since we're, okay, I'm just going to do theta right now equals 30, but not insert the value of 30, because that's just going to take up too much time. Sine of theta equals the opposite, x, over the hypotenuse, 2x. Now, what we know this to be is that, what the heck, just getting down on one knee, is that we can say that the x's cancel out. 0, and that's 0. So then we have 1 sine theta equals 1 over 2. That's just going to be our value right there. Alright, so now that we have that, now that I have that explained, alright, so now we want the cosine of 30. So now we have the cosine of theta equals the adjacent x square root of 3 over 2x. Since the x's cancel out, as we all know by basic multiplication and division, we have the square root of 3 over 2. That's going to be our value right there. Alright, so now that we have the cosine of 30, we can now figure out 60. So now we're just going to change this value right here to 60 and forget about that measly old 30. Alright, so now I already know that this and this are equal and this are equal, but I'm going to explain so that you use that mathematically by doing it right here. So the sine of theta, which is equal to, theta is equal to 60, so we're going to be doing opposite, x over square root of 3 over 2x. And then we're going to have the sine of theta equals the square root of 3 over 2. Alright, so we're going to have square root of 3 over 2, and there we go. That's going to be that part of the chart. And, wow, geez, this looks very similar. So now we're going to have the cosine of 60 equals the opposite, the cosine, or the adjacent, x over the hypotenuse 2x. So now we're just going to take that and those cancel out. And then we have the cosine of 60 equals 1 over 2. Alright, so now we have that. And since you guys don't know the identities and stuff, we're just going to go with the... Wait, we left something out here. Something small, but very usable later on. So now we have the tangent of 30. We're just going to go back to 30 here. I missed out on the tangent, so we're just going to go 30. So the tangent theta, I always like to use lowercase d, I don't care about everybody else, but that's just me. So now that it equals 30, we're going to do the opposite, x, over the square root of x to the square root of 3. So now, most of us know that this is 1 over the square root of 3, and we have that. Now, the tangent of 60 then, theta, meaning that this is going to be 60 now. I'm just going to erase this so that it's less confusing. I'm just going to erase all of that so that's less confusing. And then the tangent of theta here is equal to the 60 opposite square root of 3, square root of 3 divided by 1, x, and the x's cancel out, and we all know that that's going to be square root of 3. So that's going to be the basic. We can even look at this and just say that that's going to be true, because we can just say that that is multiplied by that, and whatever. Yeah, so that's all the basics. This is 30, 60, 90 triograms. I'm going to be filling in more of that chart. Next episode I'm going to be teaching you guys about the 45-45 triangle, all that basic stuff for this. Thank you guys for watching. This has been A148, and see you guys later.